So we're going to get started today. We're going to talk about graphing again. And so I'm going to make a nice little graph here for us. So if you're taking notes, go ahead and make a graph. All right. And remember, these are the four quadrants, 1, 2, 3, and 4. I'm going to put a point up here. We're going to say that that's at, +8. And over here at +7. So this ordered pair, we put our x component first. That's 7, followed by our y component. That's 8. Over here, I'm going to put a right there. This is going to be, we'll say -9. And then we'll say that this is -2. So this ordered pair here is -2, -9. Okay. All right, so what I want to do is express this line that these two dots make. So bear with me as I make a line there, okay? I want to express that in an equation. I'm going to teach you 3 different forms of an equation that represent a line. So philosophically, let's talk about what's going on here. A line is made up of an infinite amount of points. Okay, these points are found just like these 2 points are. You go over a certain amount on the x-axis, and then you go up or down a certain amount on the y-axis. Okay, so from the origin right here, we either go positive x or negative x, and then we either go positive y or negative y. In this case, both the x and the y are positive, and in this case, both the x and the y are negative. Okay. All right, so there's a lot of information actually that exists right here. So the first thing that we want to do is we want to find the slope. And remember, slope, as we talked about last week, is always denoted by the letter m, and it is the rise over the run. Okay. Now, it doesn't matter if we start from here and go to here, or if we start here and go to here. So I'm actually going to work it both ways. So get a different color here. All right, we're going to start from down here, and we're going to figure out how much we have to rise. So I've got to go up a certain amount, and then I've got to run a certain amount. I've got to go over a certain amount to get to that next point. Okay, so I got to figure out how far up I'm going to go and how far over. Okay, so here I know that I'm down here at -9, and I'm going all the way up here to +8. So that is a distance of 17. 9 here, 8 here, that's 17, right? What is, if you just did, well, -9 plus 8, well, that's -1. That doesn't make any sense. And this is where, if you remember when we talked about absolute value, what is the absolute value of -9? In other words, it's distance from the origin, right? The distance from the origin is +9. Then here, the distance from the origin, absolute value of 8, is 8. So now I can add them, 8 plus 9, and that's where I get my distance of 17. All right, so I know to go from here to here, I have to go 17. Now, from here over, how much do I have to go? All right, so from here to here, now I'm going to go over. So here, I start at -2, and then I'm going to go over to +7, right? So this distance here, absolute value of -2, is +2. This distance here, absolute value of +7, is 7. I add 7 plus 2, that gives me 9. I'm going over 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so my rise is 17, and my run is 9. 17 over 9. That is my slope denoted by the letter M. Okay. Now, we're going to go the other way. So let's start here and come down to here. So the first thing that we notice is that we're going to come down instead of up. Well, how many am I going to come down? I can calculate it again, but it's the same answer. I'm going to come down 8 here and then another 9 here. So that's a total of 17. Okay. But this time, I'm dropping. My rise is in a different direction. My rise is down. So my direction is what I capture with the negative sign. It's negative 17. Negative 17. Then I'm going to the left. The same amount I went to the right up here, 9. But up the direction that I'm going is to the left. And to the left is also negative. So negative 17 over negative 9. A negative over a negative results in a positive. So this 2 is 17 over 9. So regardless if I go from here to here or here to here, I'm going to end up with 17 over 9 as my slope. And you'll notice that this particular, you always read the direction of a line from left to right. So in this case, from left to right, the line is going up. As I move from the left to the right, I'm going up. Okay, so that means it's going to have a positive slope, which it does, 17 over 9. Okay, now keep that in mind. We're going to use the same exact graph, and I'll keep referring back to it, but we've calculated the slope, 17 over 9. Now, what I'd like to do is put this into an equation. So I'm going to show you 3 equations. Okay, the first one is called the standard equation. Okay, this is called standard. Then you have y minus y1, then x minus x1. There we go. That's called point slope. This is point slope form. And the standard one, we should write the word form as well. Standard form. Okay. So we have point slope form and we have standard form. Y, this is just y. That looked a little confusing. Y minus y sub 1 is equal to m, that's the slope, times the quantity x minus x sub 1. All right, then finally we have y is equal to mx plus b. And this one is called slope intercept form. Okay, slope intercept form. Sloped intercept form is the most common. The second most common is standard, and then the third most common is point slope form. In fact, your homework, if I double checked, when I made the worksheets, I didn't even have any point slope on there because it is pretty rare, but you can use it. And in our case right now, it's going to come in handy. Now, what does all this mean? Okay. So right here, A, B, and C are constants. In other words, they're going to end up being numbers. Okay. Your x, y is every single x, y on here. So in this case, 7 is your x, 8 is your y, then a and b would be some numbers. When I multiply and add it all together, I'll get another number c. So that would be the standard form. Here, my 7 would go into x1, and my 8 would go into y1. M would be the slope, and we already solved for that, so we know what the slope is. And then y and x, those would be another point. So like this y and this x. All right, and then slope-intercept form, this y and x represents obviously your 7 and 8, and then your slope, which we solved for 17 over 9, and then b here, that's as your y-intercept. Okay, y-intercept. What is the y-intercept? The y-intercept is where the line comes in contact with the y-axis. That's going to be different for every line. That right there is called the y-intercept. Okay. All right. So I know what my slope is. I don't know what A is. I don't know what B is. I don't know what C is. I don't know what the little b is, which is my slope-intercept. But I do have 2 points that I can use in any of these equations that I want. So the first one that I'm going to do, I'm actually going to use this right here. No, I'm not. I'm using this one, slope-intercept form, because what I want to do is I want to find the y-intercept. Now, how would I do that? Because I can take one of my points, either -2, -9, or 7, 8. And it doesn't, excuse me, it doesn't matter which one. So I'm going to choose 7, 8. 7, I'm going to plug in for x. 8, I'm going to plug in for y. Now, a few quick things. This line, no matter what points I choose on it, this line has a consistent slope. So when we put these equations with their actual values, the slope will never change and the y-intercept will never change for this line. Other lines will have different slopes and different y-intercepts. But this line right here, it has the same slope everywhere that you go on this line. And it only crosses the y-axis in one place. So even though I can plug in 7 for x, 8 for y, then I can do this point, -2 for x and -9 for y. The m and the b never change. Okay? And so up here, that's going to be the same thing. A, B, and C are never going to change for that line. And that's helpful because if we start with an equation like this, then if I plug in one number for x, I can get a different number y. Okay? All right, so back to this. We want to find y-intercept. So I'm going to use the point 7, 8. All right. So I'm going to use the point 7, 8. Okay. I'm going to plug in 7 for x, 8 for y, and I know my slope. My slope is 17 over 9. So let's look at that. 8 is equal to 17 over 9 times 7 plus b. Okay. All right, now I'm going to do, I can multiply 17 times 7. That gives me 119. 119 over 9 plus b. Now I can subtract the 119 over 9 from both sides. What I'm left with is 8 minus 119 over 9, and all that's equal to b. All right, now I need to find a common denominator between these two. So I'm going to multiply the top and bottom here. 8 is just 8 over 1. So 9 over 9, so that I have the same as over here. 9 times 8 is 72 over 9 minus 119 over 9. Okay. Now I'll do 72 minus 119, and that's going to give me negative 47 over 9 is equal to b. All right. 47, I'm pretty sure, is a prime number. Let me check. So what I like to do is take the prime number, divide it by several other prime numbers, and just kind of verify that it's prime. Okay. So I can't simplify this. So we'll leave it just like it is, negative 47 over 9. So if we wanted to kind of get a better idea of where it crosses the y-axis here, this is negative 47 over 9. But what is that as a mixed number? Okay. So it would be 47 divided by 9. So roughly 9 times 5 is 45. So a little bit further than negative 5. Just a little bit further than negative 5 is where this is going to cross. And that makes sense. It's negative. Down here is negative 9 for this point, right? It's in the third quadrant, negative. So negative 5 makes sense that it would cross around there. Very good. So now that I have b, I can write this equation for this line, okay? And this is what the equation looks like. Remember, slope-intercept form is y is equal to mx plus b. That's slope-intercept. Okay. So y and x will remain y and x. The slope and the y-intercept, you'll plug in numbers for those. So 17 over 9 for the slope. And then my y-intercept, remember, was negative 47 over 9. So plus negative 47 over 9. And I could simplify this by, if I add a negative, that's just subtraction. Okay. All right. So now I have this in y-intercept form. Now to convert to standard form, which is ax plus by plus c, all I have to do is put the x and the y on the same side of the equation and then make sure there's no fractions. Okay, so the first thing I'm going to do to make sure there's no fractions is I'm going to multiply both. Actually, let me go ahead and that way you guys in your notes don't get confused. This is slope-intercept form. All right, so now what I'm going to do is convert it to standard form. So I'm going to multiply 9 on both sides. 9 times y, then 9 times 17 over 9. 17x times 9 over 9 minus 47 times 9 over 9. So here the 9's all cancel, and I'm left with 9y is equal to 17x minus 47. All right, now I need to get the x's and the y's on the same side. So I'm actually going to bring the y over here. So if I do that, I have 0 is equal to 17x minus 47 minus 9y. Then I'm going to bring this number here that doesn't have x or y over here. So I'm going to add 47 to both sides. Right? And what I'm left with is 47 is equal to 17x minus 9y. Okay? So notice, and now, due to the transitive property, so if A is equal to B, then B is equal to A. So I can switch sides. 17x minus 9y is equal to 47. So this is this form. A number times x plus a number times y is equal to another number. Now, obviously, I said plus. There's a negative here. That's okay. You can also switch that to a plus using the definition of subtraction. So a number times x plus a number times y is equal to another number. And that's in standard form. All right. So let's look at and let me know if you need me to leave the notes on the screen as you're taking them. Okay. All right, so let's look at another equation, and we're going to graph from the equation. So I'm going to have y is equal to 2/3 x plus 3. Okay, so write that down. Y is equal to 2/3 x plus 3. This is already in slope intercept form. So we're going to graph from here. All right. So all right. Since this is in slope intercept form, there's two things I know automatically. I automatically know the slope without having to calculate it because it's right in the equation, 2/3. I also know where it crosses the y-axis. That's that b, 3. So the first thing I'm going to do is I'm going to come over here to the y-axis. I'm going to find 3 on the y-axis, and I know that point because the equation gives that to me. Now, I can actually go in here and I can form the line. There's two ways to do that. Okay, the first way is we can just plug in x and y's. We can plug in 0, 1, 2, and 3 for y, or for x, and see what y we get. So if we plug in 0, y is equal to 2/3 times 0, that would just be 0, plus 3, that would just be 3. And that's the first point here. That's 0, 3 right there. But we already knew that from just the equation itself. All right, next if I plug in 1, I get 1 times 2/3. That's just 2/3 plus 3. So 2/3, let me do some quick math down here, plus 3 3 would be 9/3. So 9 plus 2 is 11. 11/3, which would be 3, 3 2/3, which you already know that because 3 plus 2/3 is 3 2/3. So we could do 3 2/3. So x is 1, y is 3, and then we can go up to 2/3, so not quite to 4. And then that's how you'd work it. Okay. But the other way to do it is we already know we start at 3 on the y-axis because of the y-intercept. Then from here, since we know the slope is 2/3, which means my rise from a point is 2, and my run from a point is 3. So I'm going to rise 2, and then I'm going to go over 3. And that's going to be another point on the line. And then from here, I can go up 2, over 3, another point. And so there's actually several different ways that you can graph this line just from the equation without having to create a chart. Now, you can always create a chart, and you can plug in a number for x and then see what kind of number that gives you for y. You just need 2 points and a ruler or a straight edge, and you can draw the line. But you can also, from the slope-intercept, start at the intercept and then use the slope, up 2 over 3. And that's graphing from the equation. So now what I want to do with this equation is I want to convert this equation to standard form. So 2/3 x plus 3. So we have y is equal to 2/3 x plus 3. All right, so both my x and y need to be on one side, and then one number on the other, and no fractions. I have a fraction, so I want to get rid of that 3 in the denominator. So I'm going to multiply both sides of the equation by 3. Okay, 3 times y is 3y. Then I'm going to distribute this. 3 times 2/3 x plus 3 times 3 is 9. So this 3 and this 3 cancel, and I'm left with 2x. So 3y is equal to 2x plus 9. Now, I can do a couple of things. I can move the y over here and the 9 over there, or I can just move the 2 over here. I think it'll be easier just to move the 2 over there. Minus 2x minus 2x. So I'm left with negative 2x plus 3y is equal to 9. And now that is in standard form. This equation and the equation that we started with, these are the same equation. I shouldn't say they're the same equation, but they represent the same line. It's just expressed differently. All right, now let me double check your homework. I want to make sure that you can do what it is you need to do. Give me just a minute. All right. So the next thing I'd like to do is graph if I give you both intercepts. So let's say that I give you the y-intercept as 7, and then something called the x-intercept as, and we'll say that's -3. All right, so the y-intercept is 7, and the x-intercept is -3. All right, intercept means where it crosses the axis. So you know that this is my y-axis up there and my x-axis here. And we've talked a little bit about the y-intercept. If that is 7, then I would just go here, 1, 2, 3, 4, 5, 6, 7. I would find 7 on my y-axis, and I would put a dot there. That's a point, because that's where it crosses. Whatever line this is, that's where it crosses the y-axis at the y-intercept. The x-intercept is the same concept, except where it crosses the x-axis. And in this particular case, it crosses at -3. So from the origin, I'm going to go to the left 3 to -3 here. Go ahead and put a 7 there, -3, and there's a dot there. So now that I have 2 points, if I know both of the intercepts, I can very easily draw a line. And I've sketched this graph. Without an equation, this is just 2 points that happen to be the intercept, right? This point is 0 for x, 7 for y. This point here is -3 for x, 0 for y. I could find the slope of this line. If I look at from here to here, my rise is 7. My run is 3. My y-intercept, I already know that to be 7. So I can very easily create an equation for this line. I'll use slope-intercept form. Slope-intercept form is y is equal to the slope, 7/3x, plus the y-intercept, which is +7. And this is the equation for that line. And if I plugged in 0 for y, x would end up being -3. So it all fits together nicely. All right. Now, let's start from standard form. So let's do -6x minus 12y is equal to 9. Okay. How do I graph this one? Well, directly what we can do, if we wanted to, is we could make a chart and we can plug in values. Let's plug in 0 for x and solve for y. So if we do that, we have -6 times 0 minus 12y is equal to 9. -6, 0 is just 0. So we're left with -12y is equal to 9. Divide both sides by -12. Y is equal to +9 over -12. And we can simplify that. We can divide the top and bottom by 3. That gives me +3 over -4. And that's the same thing as -3 over 4. So I could put that in here, -3 over 4. All right, the other thing that I can do is I can put in 0 for y. When I put in 0 for y, I can then solve for x. And that's another easy thing, because anytime I'm multiplying by 0, it kind of gets rid of some things for me. So I have -6x minus 12 times 0, because now I'm plugging 0 in for y, is equal to 9. Negative 6x minus 12 times 0, so that's just 0, is equal to 9. Negative 6x minus 0 is equal to 9. That's just negative 6x. All right, divide both sides by negative 6. The negative 6's cancel. X is equal to positive 9 over negative 6. And I can simplify this one the same way, actually, dividing the top and the bottom both by 3. 3 over negative 2, which is the same thing as negative 3 halves. So my x becomes negative 3 halves. And directly from there, I can graph. So my 2 points are 0, negative 3/4, and negative 3 halves, 0. So if I were to graph that, okay, this is my y, this is my x. All right, and my 2 points are negative or 0, negative 3/4. So 0, negative 3/4. So there's negative 1. Negative 3/4 would be about right there, not quite to negative 1. And my other point is negative 3 halves, which is negative 1.5. Whoops, negative 3 halves, negative 1.5, 0. So negative 1, 2, here's negative 1.5. All right, so that would be my line right there. So from standard form, I can plug in some x and y and be able to find the line. The other thing that I can do, so with the same line, same equation, standard form, negative 6x minus 12y is equal to 9. I can also convert this into slope-intercept. So before we went from slope-intercept form to standard. Now we're going to go from standard to slope-intercept. In slope-intercept form, just so you remember, is y is equal to mx, the slope times x, plus b. All right, so here, all I have to do is solve for y. So in order to do that, I'm going to move the 6x to the other side of the equation. Minus 6x plus 6x. I'm left with 12y is equal to 9 plus 6x. And then I'm going to divide both sides by negative 12. Negative 12 over negative 12 is y. Y is equal to 9 plus 6x over negative 12. All right, but that doesn't really look like this. So first of all, the x part has to be first. Well, since I can add things in any order I want, I can just switch those two's place and do 6x plus 9 all over negative 12. But I need a plus with no common denominator between them. So what I can do is split the denominator. So I have 6x over negative 12 plus 9 over negative 12. Right? So if I had found the common denominator, which is negative 12, remains on the bottom, and then I add the tops. So I'm just going kind of backwards from that, reverse from that. Okay? Now I can do a little simplification. 6 over negative 12, that's 1/2. So I actually have negative 1/2 x. Now this 9 over negative, that's also plus a negative, is going to be a minus. My 9 over 12, that can simplify, dividing both the top and the bottom by 3. This becomes 3 over 4, right? That negative plus a negative is right here. Okay, so now I've converted it into slope-intercept form. So now I know my y-intercept, negative 3/4. So if I go back to my graph that I'd made before, and I find the y-intercept, okay, the y-intercept is negative 3/4. Well, that's right here, okay? Then I can use this, negative 1/2. So I can go down 1 over 2, down 1 over 2. And boom, you see how that falls right on that line. All right. The next graph I want to show you is y is equal to the absolute value of x. How would I graph that? All right, this one's kind of interesting because we know what absolute value means. It means the distance from the origin, okay? So the absolute value of, and let's write it out here because I think that'll make the most sense. If I just choose x's and y's to plug in, right? If x is 0, absolute value of 0, 0. If x is 1, 2, so let's say x is 1, absolute value of 1 is 1. If x is 2, absolute value of 2 is 2. Easy enough. But watch this. If x is negative 1, the absolute value of negative 1 is also 1. And the absolute value of negative 2 is also 2. So we have a point at 0, 0. Okay. We have a point at 1, 1. We have a point at 2, 2. Then we have a point at negative 1, 1, and negative 2, 2. So the absolute value equation does this. Creates this corner as it comes down and out. So it creates a very interesting graph. It's not linear, right? It's not a line that keeps going in the same direction. It sort of mirrors itself on, in this case, on either side of the y-axis.